Hello everyone. Today we are delving into the intriguing world of cache memory, a driving force behind optimizing CPU performance. Cache memory acts as a high-speed intermediary between the CPU and main memory. It stores frequently used data, reducing the time the CPU spends waiting for information. Types of cache memory. We have the level 1 cache, the level 2 cache, and the disk cache. The level 1 cache is inside the CPU and it houses recent data for immediate access. The level 2 cache is adjacent the CPU and it expands storage capacity. The disk cache temporarily stores frequently accessed data from the hard disk. Imagine the CPU searching for data in the cache, but the data is not there. This is what we call a cache miss. You must then fetch the required data from slower main memory, leading to a temporary delay in execution. Performance, metrics, and equation. Performance metrics are measures used to assess the effectiveness of cache memory. We use equations to quantify these metrics. These equations include hit ratio, miss ratio, average access time. Hit ratio measures successful cache hits to total accesses. A higher hit ratio indicates efficient cache utilization. Miss ratio represents cache misses in relation to a total accesses. It's complementary to the hit ratio. Average access time balances cache hit and cache miss times. It is calculated as a weighted average of cache hit time and cache miss penalty. Techniques to improve cache performance. 1. Reducing hit time. This is refining cache access mechanisms for speed. 2. Reducing miss penalty. This is minimizing delays during cache miss handling. Reducing miss rate, that's 3. This strategizes to heighten the likelihood of cache hits. 4. Reducing miss rates times miss penalty. This is overlapping cache access and data retrieval. By this, we can conclude that cache memory plays a pivotal role in optimizing CPU efficiency. By understanding its dynamics, you are equipped to enhance cache performance and elevate the overall computing experience. Thank you.
Hello guys, you are welcome to my presentation in Right Group N. My name is Empire Michael Kike, and today we are going to be talking about cache performance. Now, in the realm of computing, speed is of essence. Imagine having a super fast processor but being bottlenecked by the time it takes to fetch data from the main memory. This is where caches come into play. Caches. What are caches? Caches are small high speed memory units that sits between processor and the main memory. They store frequently accessed data to reduce the time it takes for the processor to retrieve information. And that's what cache performance is all about, making sure these caches work perfectly. Now we have two primary principles of cache performance: temporal locality and spatial locality. Now, temporal locality refers to the tendency of programs to access the same data repeatedly over a short period of time, while spatial locality, on the other hand, involves accessing the data that's stored close to recently accessed data. When cache performance is optimized, we experience what's known as cache hit. This is when processor finds the data it needs in the cache, resulting in a significantly faster data retrieval process. However, when a processor can't find the required data in the cache, it results in cache miss, causing a delay as the data is fetched from the slower memory. To measure cache performance, we often use metrics like hit rate and miss rate. Thank you.
Hello guys, my name is Daniel. I'll be talking about cache directories. First of all, a cache is a small memory unit that stores frequently accessed data. So when I say a cache directory is also known as a cache folder. The allocations on a computer or a network where temporary files, and data are stored. These directories are used by various software applications and operating systems to improve performance by storing frequently accessed or recently used data closer to the processor or memory, reducing the need to retrieve it from slower storage devices. Cache directories can contain a variety of files, such as web page elements, application data, system files, and more. They help speed up processes by allowing quick access to frequently used data, reducing the time it takes to retrieve information from the original source. So cache directories contain more of many files, which is different files. It is important to note that cache directories are typically managed automatically by the operating system or software application, and users generally do not need to interact with them directly. However, in some cases, users may need to clear or delete cache directories to free up storage space or resolve issues related to outdated or corrupted cache data. Here are some of the benefits of using cache directories. It is important to note that the cache directory can become cluttered over time. It can lead to performance problems. It is therefore important to regularly clean out the cache directory. So when you regularly clean out the cache directory, it can improve the performance of your machine. Improved performance. That is one of the benefits of using cache directories. Cache directories can significantly improve the performance of systems and applications by storing frequently accessed data in a temporary location. The second one is reduce bandwidth usage. Cache directories can help to reduce bandwidth usage by storing frequently accessed data locally. This can be especially beneficial for organizations with limited bandwidth. Increased reliability. Cache directories can help to improve the reliability of systems and applications by improving a local copy of frequently accessed data. This can be helpful in the event of a network outage or other description. So we are going to some of the risks of using cache directories. Data loss. If the cache directory is deleted or corrupted, the data that is stored there may be lost. So when there's a corruption or a file is deleted from the cache directory, you may or the data may be lost. Then the second one is security vulnerabilities. Cache directories can be a potential security vulnerability if they are not properly secured. This is because they may contain sensitive data such as passwords or credit card numbers. Performance problems, that is the third one. If the cache directory become too large, it can slow down a system or application. Now, this is an image to show an explanation of the cache directory. So this is the folder here and this is the cache in it. So just an image to show an explanation of the cache directory. So in conclusion, the cache directories can be a useful tool for improving the performance and reliability of systems and applications. However, it is important to be aware of the risks involved and to take steps to mitigate them. Thank you, everyone.
Good day to you guys and welcome to my presentation. My name is Kilson Kwamina Otriel, Group N, and for today we'll be treating the topic the LRU replacement scheme. The general topic is the cache directories, cache performance in the LRU replacement scheme. But this presentation I'll only be touching on the LRU and replacement scheme. So let's head into it. So one may ask, what is the LRU? So the LRU stands for least recently used, and it's a popular cache management policy used in computer systems and databases. The LRU aims to decide which cache entry should be replaced with a new entry, and with the new entry needs to be inserted into the cache that is already full. So the basic idea is just to remove the least recently used item from the cache, assuming that the items that haven't been accessed for a long time are less likely to be accessed again in the near future. So it's just saying that the items that are not the least recently used items that are in the storage space are going to be replaced with the new ones, so it keeps on going like that in that cycle. So the new ones are in front, the old ones are at the back, the new one replaces the old one, and the cycle continues like that. So the RRU updates and replacement scheme can be explained as follows. So 1. Keeping track of usage order. In an LRU based cache, each item that is brought into the cache is tagged with a timestamp or sequence number, indicating when it was accessed or brought into the cache. 2. Updating whenever a new item is accessed or needs to be stored in the cache. So if the cache has available space, the new item is simply added to the cache with a current timestamp or sequence number. If the cache is already full, the item that has the oldest timestamp or lowest sequence number is removed from the cache to make space for a new item. So cache hit. When an item is accessed that is already present in the cache, it is considered a cache hit. In the case of cache hits, the access item timestamp or sequence number is updated to the most recent value to reflect that it was just accessed. So let's say the item you selected first is given a number. The item you selected last is also given a number. So when it is replaced, a new number is given to it, and so on and so forth. So cache miss. When an item is accessed that is not present in the cache, it is called a cache miss. In this case, the item is brought into the cache and assigned a current timestamp or sequence number. So if the cache is full, the least recently used item is removed to make space for the new item. And what are some of the advantages and disadvantages, advantages and drawbacks of the LRU? So a simple and intuitive scheme that works well for many scenarios as it tends to keep recently used items in the cache. However, it can be challenging to implement efficiently in hardware or software, especially as the cache size grows due to the need to constantly track and update the usage order of cache items. So, um, what all this is saying is that the the cache, yes, imagine you have a small storage space to keep important things in handy. So every time you touch or look at the thing in the storage space, it gets moved to the front of the line, right? So as new stuff arrives, when you get something new, there is no room. You kick out the thing at the back of the line that you haven't used in a long time. Then if you want something and it's in the storage space, you move it to the front because you're using it again. And to yes, you move it to the front because you're using it again. And if you need, oh sorry, so whilst this works well for remembering what you recently used, it can become a bit of a hassle to manage all the time. So in computer systems, similar ideas are used to decide what data or what data to keep or remove in a cache. So remember, the key idea is to keep the things you have recently used close by and let go of things you haven't used in a while to make room for the new things. Yes. So to end this presentation, the LRU updates and replacement scheme prioritizes keeping the most recently used items in the cache. So when space is limited, a new item needs to be stored, like I said. The oldest or least recently used item is evicted to make room for a new item. This approach is effective for maintaining a cache with relatively accurate representation for recent data usage patterns. Yes. So if let's say I opened some documents a while ago. So let's say I opened 4 documents a while ago. The oldest document I opened will be at the back. The newest one I opened will be right in front. When I select another one, the recent one I opened moves to the back of the line. I select another document, it moves to the back of the line. So as it goes like that, the storage spaces is being filled. So as a new item comes in, one is cleared to make room for another one. That is basically all that the LRU and a replacement scheme is talking about. So thank you for listening to me in my presentation, and I hope my teammates can also assist you to understand the other topics as well. Thank you very much, and goodbye.
Hey guys, this is Perry from Group A. So I'm talking about the LRU update and replacement scheme. This is the continuation. So the advantages of LRU. LRU has several advantages such as being an easy to understand and implement and its effectiveness in scenarios. Easy to understand and implement. Effective for data with temporal locality. Raw word application. So they're easy to understand and implement. LRU simplicity lies in its concept of tracking, the order of data access. It's easy for developers to grasp and incorporate into their systems, making it practical choice. Effective for data with temporal locality. LRU works well when there is repeated pattern of accessing certain data shortly after it was accessed before. It is common in scenarios like reading files or web pages where users often revisit recently viewed content. Raw word applications. Error is applied in various raw word scenarios, including operating systems to manage memory efficient and web browsers to cache frequently visited web pages, enhancing user experience. Challenges with LRU: sensitivity to access patterns. LRU performance can suffer if there is sudden change in the pattern of data accesses. For instance, if previously unused dataset suddenly becomes hot, LRU may take some time to adapt and may not respond optimally initially. Resource intense for tracking access order. Keeping tracking of the order in which data is accessed can be computationally intense, especially in large-scale systems with a high rate of data access. Raw word application, operating system managing memory, web browser caching web page, other relevant domains. Operating systems are allowed to efficiently manage limited physical memory, which is the RAM. It ensures that frequently used data remaining in RAM for faster access, enhancing overall system performance. Web browsers caching web pages. Web browsers employ RIE to cache recently visited web pages. This reduces loading times of frequently accessed sites and improves the user experience. Other relevant domains. LRU can also be applied in da- database management, where frequently accessed recordings are kept in memory to reduce disks, and in content delivery network, which is the CDNs, to serve popular content quickly to users. So the importance of LRU, foundation, foundational concepts, impact on computer systems and application, memory management and caching systems. Understanding LRU is crucial for professional workers, for profession, for professionals working with memory management and caching system, as it forms the basis for many caching strategies and algorithms. Impact on computer systems and applications. LRU performance directly affects the efficiency and speed of various computer systems and applications, making it a pivotal concept to master. Memory management and caching system. LRU plays a central role in optimizing memory usage and improving system performances in critical areas of computing. So this is the conclusion. Thank you for your attention. That concludes my presentation and you update and replacements.